Today's video is section 3.2, the mean value theorem, and Rolle's theorem. So let's begin with the mean value theorem. If f is continuous on the closed interval a,b, and f is differentiable on the open interval a,b, then there exists a c in the open interval a,b such that f prime of c, which in other words, that slope. How do you get slope? That is a y, here's the x. Here's the y, here's the x. So f of b minus f of a over b minus a. So this is on the f function, and then some point on c on the f function, this slope equals this slope. The slope of the tangent line equals the slope of the secant line. In other words, let's take a look at a picture. What it's saying is this closed interval from a to b. So those are 2 points on my f function. And then you have your output of f of a and your output of f of b. So how do I find slope of this secant line? It's f of b minus f of a. The two y's are subtracted, and the b minus a are subtracted. That's how you get slope of a secant line with 2 points. How do you get the slope of a tangent line? Well, that's taking the first derivative. What the mean value theorem is saying, that if I have whatever slope this is, there's some point c somewhere inside of this open interval from a to b, some point c in which these two slopes are equal to one another. These two slopes are equal to one another. The slope of the secant line, slope of the tangent line. That's the mean value theorem. The Rolle's theorem is just a special case. Rolle's theorem. If f is continuous on the closed interval a through b, and f is differentiable on the open interval a through b, then if f of a equals f of b, these two y's are equal to each other, then there exists at least one c in this open interval a through b such that f prime of c equals 0. This slope equals 0. Well, this slope must equal 0 also. If I have some interval, closed interval from a to b, and the two y outputs are also equal, so if the two y's are equal, that's some horizontal line. So let's take a look at that picture. So what this special case of the mean value theorem, called the Rolle's theorem, is stating that these slopes are going to be equal to 0. So here is a through b, and that the outputs f of a and f of b are both equal to each other. Okay, so let's go back to looking at this graph again. So I have 2 points, the f of a and f of b, which is the y for these two, are equal, which means that's a horizontal line. That slope is 0 of that secant line on f. That means by the Rolle's theorem that there's some value c in this open interval from a to b in which the slope of that tangent line will be parallel, in other words, also 0. That's all that is saying. So now let's go ahead and let's work out two problems. In fact, let's first look at some graphs. Let's look at this graphically. So these three, I could not use Rolle's or mean theorem because this point here is not differentiable, and to use Rolle's or mean value theorem, that f must be continuous on some closed interval from a to b, and f must also be differentiable. Well, I can't use them because it's not differentiable here, It's not differentiable here because that would be undefined. And then here it is not continuous. I would have to pick up my pen for that function. So that would be reasons why I cannot take the Rolle's or mean value theorem. Let's go ahead and let's do a problem for Rolle's theorem. That's the special case in which if I have f of a equals f of b, then there's some c in the open interval from -1 to 3 such that the slope will also be 0, such as this one. Well, here's my function, and here's my closed interval from -1 to 3. So f is continuous on the closed interval from -1 to 3. It's continuous. Nowhere do I pick up my pen. I just keep on going. And it is differentiable everywhere because this is just a polynomial on the open interval from -1 to 3. So let's go ahead and let's plug in my a and b, which is my endpoints. So f of -1 is 0. So I have my first ordered pair, -1, 0, for my first point for my secant line. F of 3, the other endpoint of that interval, that produces a 0. So there's the second point, 3, 0. So when I graph those, -1, 0, and 3, 0, that slope is clearly 0 on that secant line. I don't know, maybe it looks like this. Oops. At those 2 points, it produces a slope of 0. So yes, I do have that on this function. So then there is a c somewhere in between -1 and 3, not including those endpoints, in which the slope of that tangent line is also equal to 0. So I guess what I should do is take the first derivative. And in taking the first derivative, I have to use the product rule. So I take the derivative of this, which is 1, leave that alone, plus leave this alone, take the derivative of this. I'm going to go ahead and use that new technique of factoring out that x plus 1. And then I have an x plus 1 left, plus 2 times this x minus 3. I'm going to multiply that, so I have terms. Combine those like terms. There is my first derivative. And that is the slope of the tangent line for function f. I'm going to look for some c in which this slope is 0. So let's set it equal to 0. I'm going to set each one of those equal to 0. I get -1 and 5/3. But it has to be on the interval -1 to 3, not on the closed. So -1 does not fit in, so it must only be 5/3. That is my c value. So f prime of 5/3 equals 0. That slope at this point is 0 for the tangent line. That's an example of the Rolle's theorem. Next, let's do the mean value theorem. Mean value theorem. So now the slope doesn't have to be 0. So the slope of the tangent line for some value c, which is in between -1 and 1, that slope has to be equal to the slope of some secant line, y2 minus y1 over x2 minus x1. Well, this is my a and my b. So let's go ahead and, well, first we need to state that f is continuous on the closed interval, and f is differentiable on the open interval. Nowhere am I going to pick up my pen. That's just a polynomial. And nowhere is this a step function or an absolute value function. So I may go ahead and continue. So I'm going to substitute in the 2 endpoints, put in -1 into that function, and I'm going to get a 0. So the first ordered pair is -1, 0. I'm going to put in the other endpoint 1, and so that's 1. 1 minus 1 is 0. 0 plus a -2, that's just all -2. So I get the ordered pair 1, -2. These are 2 points on f. You connect those 2 points with a line, that's a secant line. So let's take the slope of that secant line. So y2 minus y1 over x2 minus x1. It's -2 over 2 equals -1. So this is the slope of this secant line, and this has got to be the slope of a tangent line for some value c. Well, let's go take the first derivative. Well, in fact, let me get you my original function again so you can figure out how to take the first derivative. There it is. So x times x squared minus x minus 2. So again, I need to use the product rule. Take the derivative of this, which is 1, copy, plus, copy, take the derivative, which is 2x minus 1. I'm going to go ahead and multiply that through, get a bunch of terms, combine them. So that's f prime of x, or the first derivative, in other words, the slope, anywhere in f, there's the slope equation. But I want this slope, which is from the secant line, to equal the slope of my tangent line for some value c. I wonder what c it is. So I'm going to set this all equal to -1. I wonder what x, that'll be my c, will have a slope of -1. Well, I need to solve for that x, or in other words, that c. I'm going to add 1. To solve a quadratic in order to find that x or that c, I would try to factor, but this is not factorable, so I'm going to use the tried and true quadratic formula. -b plus or minus b squared minus 4 times a times c all over 2 times a. So I get 2/6 plus or minus, that's, that becomes positive, that's a 12. Plus 4, that's 16. Square root of 16 is a 4 over 6. Clean that up, that's 1/3. Simplify that, that is 2/3. So I have 1/3 plus 2/3 and 1/3 minus 2/3. So 1/3 plus 2/3 is 1. And 1/3 minus 2/3 is a -1/3, but it has to be in this open interval from -1 to 1. That does not work, so it must be this value. That's my c. So let's actually take it a step further, as you will in some of your homework. The equation of a secant line, we'll call that line 1, y1. That is, for these 2 points, we're going to write the equation of a line through those 2 points. And so how do I do that? I'm going to use the point slope form. We found out that the slope is -1, and I'm going to grab the ordered pair -1, 0. I've already grabbed the slope -1. Now let's put that in for the y and that in for the x, which is what I did. Now I'm going to clean this all up. There's the equation of the secant line, -x minus 1. Let's get the equation of the tangent line. That's through c. And so for c, I knew my c was -1/3. What I had to do was plug that back into the original function to get that ordered pair, because I need a point for point slope form. After I plugged it all in and did all the careful mathematics with the fractions, I got 14 over 27. And so that is the y and that is the x. So I put -1/3, which makes it +1/3. The positive 14 over 27 becomes minus 14 over 27. And my slope is -1, because that's point slope form. And now I'm going to multiply that, and I'm going to add that to the other side. So negative, negative, add. Now I need to combine those. I need to make the common denominator of 27, so that would be times 9 times 9. So a positive 14 and a -9 is +5. So the line, the equation of the line for the tangent line, I'm sorry, you can't see that, is -x plus 5 over 27. And yes, these two lines are both parallel. They have the same slope of -1. Your homework assignment is section 3.2, 1, 2, 13 through 19 odd, 23, 33, 34, 37 through 45 odd. Thank you.